for RDT. This is task number 4. You'll see that listed on the slides there are 3 different unit codes. That's because there are 3 competencies associated with this particular unit of work and the associated assessment. ICT 301 is relating to the user documentation. This unit is not HSE examinable. The other 2 units, ICT 302 and ICT SAS 308, are both HSE examinable, and these slides aim to run you through the HSE specific content in preparation for your examination. We're going to get started specifically looking at the first unit of competency around operating systems, the setting up, installation, configuration and optimization of operating systems. So here's lesson 1. In today's presentation, we're specifically looking at your ability to explain the purpose and functions of an operating system under the syllabus key heading of operating systems. So we'll get started. The purpose of an operating system is to act as a medium between the physical hardware and the software of the computer. It gives the user the ability to interact with both this hardware and this software. It is the foundation software that the whole computer is built upon. The operating system software is responsible for managing all of the other software applications, where they're going to be installed, how they're going to run, which ones are going to be prioritized, etc. And this comes back to the operating system's primary purpose of allocating and using the computer's resources. So this is all about how can we access the hard drive and what sort of security settings are around that. How is the processing unit working? At what speeds? What do we need to do to manage it to make it more efficient for the user? How is the hard disk storage being set up? What's the format of it? What's the file structure of it? Where are all my files stored? How do I find them when I need them? All of that management is happening live by the operating system when you are using it. Most importantly for us in the primary examples we're going to be working with is that it provides us that user interface. Now specifically we're talking about a graphical user interface when we're talking Windows 10, Mac OS Catalina and also our Linux version of Ubuntu. This graphical user interface, GUI, graphical user interface, or GUI as we like to nickname it, is the computer's ability to represent graphically what is happening. Now you're very familiar with the idea of when you want to open Google Chrome, you would locate the Google Chrome icon, you would click on it, and Chrome opens. This is thanks to the graphical user interface. You are graphically pointing a cursor to this icon. When you double click on it, it sends the command to open that application. If we were not using graphical user interfaces, we would be using command line interfaces like command prompt, where you would type in your command codes and you would have to read through the operation of your computer. You wouldn't be able to visually see graphics and icons. So let's talk more about the basic function of the operating system. 3 different things I'm going to talk about. The first is file system structures. Then I'll talk about memory management and this whole idea of memory versus storage and also virtual memory, as well as how process schedules are managed and the idea that your operating system is responsible for that. You can see on the screen there's a bit of a graphic there about all of the different things that an operating system is responsible for. So we'll start with file system structures. There are 3 main file system structures that we're going to learn about. The first is the FAT32, then we've got NTFS and Apple's HFS system. I've listed our 3 example operating systems. I'm going to be referring to these as our main 3 that we talk through every time we're referring to examples here, and that's so that we can write about them in the HSE and in our preliminary examinations, giving good quality examples that are up to date. At the time of recording, Mac OS Catalina is the most up-to-date, Windows 10 is the most up-to-date, and Ubuntu is still an up-to-date piece of Linux software. The FAT32 file system structure is a very old and slightly outdated system for structuring and organizing files on hard drives, on our storage. The benefit of being a little bit old and well known is that all operating systems are able to use it. You can see I've got a green tick for both Windows 10 and macOS Catalina, as well as Ubuntu. All three of these systems can read files from a FAT32 drive. They can also write files to a FAT32 drive, which is particularly important. Why then wouldn't we continue to just use FAT32? Why would we invent these other potentially non-compatible systems? Well, the reason is the file size limitations. And with FAT32, you'll see that the limitation is 4 gigabytes. What this means is no individual file over 4 gigabytes can actually be stored on a FAT32 drive. Now, you're probably not too familiar with this as a problem in your modern computing experience, but if you reflect back on your use of USB flash drives, you may have at one point in your life come across an issue relating to FAT32 which you didn't realize. Perhaps you had an 8 gigabyte USB drive, you plugged this into your computer, you had a 4.5 gigabyte video file that you wanted to put onto your USB stick, onto your flash drive. But even though there was 8 gigabytes of space available, the file wouldn't transfer and it said insufficient space available. You were perplexed, you couldn't work it out, so you just went and got a new drive. The very likely reason for that is that the USB flash drive was formatted as FAT32, which means even though there was 8 gigabytes of space available on the drive, because of the individual size limitation of 4 gigabytes, your 4.5 gigabyte video file physically wouldn't be able to be stored. The second example there is the NTFS. NTFS was designed for Windows specifically as sort of a new version of file systems. Windows 10 obviously can read it and obviously can write it. Ubuntu can also read it and write it. Mac OS Catalina can read it and can write it, but you'll notice there is a small asterisk there. And that's because in order to write to an NTFS drive or to read an NTFS drive, you need to download additional third-party software to use this on a Mac. The example of a software that I use for this is Paragon NTFS File Viewer for Mac. Free piece of software. It actually usually comes pre-installed on such hard drives so that when you purchase them, it says, hey, go download or go install this software so that you can use it on your Mac. It's very straightforward. Once you've got it installed, it's very easy to use and it's not confusing at all. It's just that initial restriction that you can't write to. Now with NTFS, because of this new way of formatting the file systems, we have an increased file size limit of 256 terabytes. That is absolutely enormous. What that means is one individual file that's 256 terabytes in size could technically be stored on an NTFS drive. It's unlikely we'd come across one of those in our ordinary everyday usage, but if you worked in a multimedia industry or in a company dealing with large data, such as a data warehouse or data mining service, those sorts of files would be fairly common, and you potentially may have the issue where NTFS is not suitable for your purposes because it's too small and too restrictive. And that's where Apple's HFS system comes in place. Now, I'm specifically looking here at HFS Plus, which is a slightly advanced version of HFS. And again, you're going to see all three operating systems can read it. But again, in order to write to it, there are some limitations in terms of third-party software you would need for Windows 10 and for Ubuntu. Now, you're looking at the screen and you're seeing that the file size limitation is 8 EBs. It's not a typo, I didn't mean GB, and I didn't mean TB. It's not 8 gigabytes, it's not 8 terabytes. It is 8 exabytes. Now, if we're thinking about file sizes, an exabyte is equivalent to 1,000 terabytes. It's an enormous amount of file. So, we're not saying here that there are files 8 exabytes in size around the world right now that we need stored and Mac was the answer to that. Mac have just developed a file structure or a file system that is expandable and can go up to those limitations. It's unlikely anyone would ever need it, but it's good to know that they're thinking about the future and our potential needs down the track. Now we're looking at memory management. All of our operating systems use RAM. That's part of a computer that's needed in order for it to run, and your RAM is volatile. That means when your computer turns off, everything that's stored on the RAM is wiped or deleted. Okay? There's no saving what's on your RAM unless you have gone in and saved it to your storage device, such as your hard drive. Because of that, we'll just talk about virtual memory. And the answer is all three of our example systems support virtual memory. Virtual memory is this process where your computer pretends it's got more RAM than it does. Now, if you're limited to 4 gigabytes of RAM like I am on some of my older computers, you can pretend to have more using virtual memory. What your operating system does is selects a small section of your hard disk and says, I'm going to use this small section here as if it's RAM. And it adds that to the paging file system to enable faster access to files. Now, accessing your hard drive is slightly slower than accessing your RAM. So as a result, the things that you are using, the applications and the processes happening right now, are happening on your RAM. The things that you have open, maybe sitting in the background that you're not using right now, are probably being moved across to your virtual RAM. They're still ready to be used, but it'll take a little bit longer to get to them than the instantaneous feeling you get from RAM-based memory use. Now, Windows 10 enables you to change the virtual memory allocation, but by default comes with 2 gigabytes for a 32-bit Windows 10 or 4 gigabytes for the 64-bit version. These are the defaults that come. You can increase or decrease as required. macOS Catalina doesn't actually have a limit on virtual memory allocation. And so for the purpose of illustration, we've written the number here, 18 exabytes. Again, exabytes. We're talking that enormous file size. What this means is your Macintosh computer is going to go to every end possible to make sure you can run as many things as you want without stalling your computer. It will just keep using more and more of your hard drive as it needs to, based on the number of things that you open. Again, the things that you're using actively right now are sitting in your RAM. The things that you have open that you're not actively using are being stored back on your hard drive in this virtual memory location or virtual RAM. With Ubuntu, yes, you have virtual memory. There probably are some configurations around how to change it, but by default, the virtual memory or virtual RAM that's there, or VRAM as you may have heard, that is being used for Ubuntu matches whatever RAM you've got installed in your system. So if you have a computer with 4 gigabytes of RAM, then you will have 4 gigabytes of virtual memory set up by default with your operating system. Next, we're going to talk about security and the comparison between the security issues potentially around each of these operating systems. When we're talking virus likelihood or how virus prone an operating system is, the real answer to that is if there is a large user base, e.g. lots of people around the world are using that operating system, then it's beneficial for a hacker to create a virus for that operating system. So if we're saying that Windows 10 is one of the most widely used operating systems in the world, then people that are maliciously developing software like viruses would intentionally create them for Windows 10 because of how many people are using it. Because macOS Catalina slightly less people are using, because it's really limited to people that have an Apple device, they're less likely to have a virus created for that operating system. And then further down the trail with Ubuntu, because it is even more unlikely that someone is operating Ubuntu on their computer, there is even less likelihood of a virus being developed for that. Now, it's not saying they don't exist at all, and it's not saying that they're less severe. It's just saying the likelihood of them being created is slightly different. Now, the reason behind some of the changes in security exist is to make sure that viruses can't just go in and destroy everything. Your operating system vendors like Windows, like Apple, are actively going out of their way to try and keep your data safe. They don't want you to get viruses. They don't want your information to get compromised. So in all three of these operating systems, there's been a recent change over the last 5 or 10 years where the person using the computer isn't actually the most powerful person or the powerful user that exists on the computer. You're like, oh, but I'm the administrator on my computer. I am the most powerful. Well, even when you're signed into your Mac as the administrator, you operate as a normal everyday user for the whole time you're using your Mac until it gets to times when you need to be an administrator. And your username and password will unlock the administration responsibilities, such as installing software and things like that. But to prevent viruses from just taking advantage of people that are permanently signed in as administrator, our operating systems now force you to re-sign in each time you need to do one of those potentially dangerous tasks. So if you need to install a new piece of software, on all 3 operating systems, you'll be asked to put in your username and password for an administrator again to authorize that installation. What that means is it prevents you from having a virus automatically installing itself, particularly in the case of a worm that's replicating over and over. Now, when we're talking about security system software, Windows comes with its own built-in security system, and this is the Windows Action Center and the Security Center. This has a free subscription as a result of buying a Windows license. You get access to this virus protection software. It updates its virus definitions regularly and is quite secure. macOS Catalina uses a whole heap of different bits of software. File Vault to encrypt your information. It uses app sandboxing, which is where each application opens sort of on its own, separate from the rest of the applications, so one can't interfere with another. You've got the Gatekeeper program and Find My Mac. All of these are around keeping your system nice and secure. And with Ubuntu, you've got your firewall, physical and software, hardware firewalls, and those are available for both Windows and Macs as well. So just to recap on virtual memory for those of you that might have missed it there, virtual memory is where your operating system picks a small part of your hard drive and pretends that it's RAM. The first thing that happens is the things that you're not using, your operating system puts those and stores them onto the hard disk because it wants the RAM to be used for the things you're using right now. And you'll see there's this little cycle I've got on the screen, and the little pages, they're representing the paging files. They're cycling between the RAM and the storage as they're needed. Sent over to the storage when they're not in active use, brought back to RAM when they are in use. So let's then talk about process scheduling. The prime aim of your computer's process scheduling system is to make sure that your computer is busy all the time to minimize the response for all of the programs that are happening. It does this by developing a task queue, so all of the things that you need done go into the queue. When there's space available, it actions them and then adds them to the completed list. The process scheduler decides which things run and when, and it has the ability to pause things, put it back on the queue so that it can start new things that are higher priority. This means, as a really basic example, if you had a computer backup happening in the background of your computer because your computer was sitting idle, and then suddenly you started using all of the processing power to render a video, your computer will very likely just suspend the process of backing up your computer, put that on hold, add it back to the queue so that it can focus on the thing that you've requested it to do. Now, your computer does a really good job of this, and you don't need to do anything because the operating system is in there making sure this happens all automatically for you. Now, we're talking types of operating systems now. We gave some examples of operating systems, e.g. we spoke about Windows 10, we spoke about Mac OS Catalina, and we spoke about Ubuntu. But we're now going to talk about the different types of operating systems that exist. The first I'll mention is batch. Batch systems are where jobs or processes are stored up during working hours, and then when there's an opportunity because the computer's not busy, or perhaps it's programmed to happen at a certain time or a certain day, all of those processes that are stored in the schedule are actioned. This is really useful when the computer that needs to process all the files might be busy throughout the day and you want to minimize its impact on your computer operations, so you schedule all of those other processes that can happen later to happen overnight. If I'm thinking of some examples here we might be talking about payroll systems, particularly for your place of work, and also transaction systems for any retail businesses you might have. Thinking about payroll, on the day-to-day, you go to work, your boss pays you, they put in your start time, they put in your finish time, and they add it to the payroll system. It gets stored there each night, and then at the end of the week on payday, the stored up pay is then processed so that you receive one single payment, which is all of your individual shifts added together, and it's processed and paid into your bank account. That happens on a weekly basis or potentially a fortnightly basis, and it's done as a batch. All of those daily pays are saved up so that it only needs to happen once per week. There are real-time operating systems. This is where the operating system guarantees that it can receive, analyze, and produce output within a guaranteed time frame. Now, we say almost instantaneous most of the time, but we know that sometimes our computers are running slower, or they might be lagging because you're really putting some pressure on the operating system and the processor, but it's happening in a guaranteed time frame. It's happening as fast as it can right then, right now. Single user systems are obviously where a single person is using the system. It doesn't have multiple people logged in at once. But single user can be broken up into either single task or multitask. Now, when we speak about single task operating systems, this is where the operating system is only doing one single thing at a time. Now, I used to use the example of a phone here because back in the old days when you had your mobile phone, your Nokia 3310 for example, you could either send a text message or you could make a phone call. You wouldn't be able to text while on the phone. You wouldn't be able to scroll through Facebook while on the phone and those sorts of things. Single task systems don't really get used all that often in our modern day. But if you want us to think of an example, the sign-in computers that we have at our front office at reception of the school, when you sign in late to school, that computer only has one login and it only has one thing happening on it at a time. And it's dedicated just to signing people in. In a multitask system, the computer or the operating system is able to do multiple things. Now, I'll go back to my phone example. I know that I have been on the phone, on speakerphone, talking to my mother, and at the same time I could be reading emails, I could be scrolling through Facebook or Instagram and those sorts of things. Additionally, I could be listening to music while browsing the web on my computer, while at the same time my computer could be exporting or rendering a video. So when your computer or your operating system is able to do multiple things at a time, then it becomes a multitasking system. Our final example there is multi-user systems. This is where we start talking about servers, where multiple people can be logged in at the same time using the computer's resources. Now, each person might have their own monitor, their own keyboard, and their own mouse, but they are accessing the same system all at the same time. Now, in order for this to work, you need some pretty serious processing power, and you need some specialist server operating system software, but it's definitely something that's doable, particularly in the idea of when we think about university computers and TAFE computers, where there are multiple users sharing library-based computers. This happens quite a lot. Now, when we're talking about the commonly used operating systems, I've got a couple of other examples there. So in case you're not familiar with Catalina, I've got Mojave and High Sierra, before that Sierra, Snow Leopard, etc. You've got Windows 10, 8, 7, XPs, 2000, all the way back to 1995, which was the first version I used. You've got Linux, Fedora, Cannicles, Ubuntu. But the key thing here I want to talk to you about is licensing. There are two main ways that software, operating system software, is licensed. The first I'll mention is open source. Open source software is software that is given to users for free. Here is the software, use it. Not only that, but feel free to change it. Here is all of the code for the software, and you're allowed to make changes to it. Now, why would you give someone the ability to edit and change your operating system? Well, this is really for advanced computer users that wanted to either develop their own skills or they had some custom requirements for their operating system that was needed. The real restriction here with open source operating systems is that you need to acknowledge the original source code, and if you're making changes based on that operating system, you need to share those changes back with the wider community. Okay, so this is all about empowering the computer world and letting everyone have a go. When we're talking proprietary software, this is where a company owns it, you pay a license to access it, and you're not allowed to make any changes whatsoever, and you're certainly not allowed to claim it as your own. For all of these, you require some really basic computer parts. You need a monitor, a keyboard, a mouse, etc. But the one real outlier here is that Apple operating systems, other than doing some little dodgy configurations around the place, are really restricted to Apple devices. You can't easily get Mac OS Catalina and install it on a PC. So that's the main real thing we'll mention here. Now look, that's the end of our first set of slides on what is an operating system, the features and functions. There's quite a bit there, so feel free to go back to this video, have a look through some other sections if you need to, but update your notes, and good luck answering the quiz questions that are associated. Thanks very much.